Welcome to our remote learning produce food safety webinar series. My name is Ashley Skinner, and I'll be the host for today's webinar. This series is funded by the USDA and is led by our PI, Dr. Michelle Daniluk from the University of Florida Citrus Research and Education Center located in Lake Alfred, Florida. This project is in collaboration with Florida Agricultural Mechanical University with PI Dr. Harriet Paul, located in Tallahassee, Florida. Our overall goal with this community outreach project is to develop innovative and engaging remote learning produce food safety curriculum that is highly accessible to diverse growers, particularly small and beginning farmers, in order to equip them with increased food safety awareness and the skills to adopt proven food safety risk reduction practices. To do so, one of our aims is to deliver instructor-led workshop webinars to diverse audiences from across Florida and the United States. Today, we have some participants from FAMU. Welcome, Jamesia Henderson, Almondo Moraine, Maxo Etienne, Bethany Noel, and Joy Adkins. And finally, we have Taylor O'Bannon from the University of Florida. She is a state specialized extension agent and is our featured presenter to teach us about cleaning, sanitizing, and monitoring. Take it away, Taylor.
Well, thank you, Ashley, and thank you all for being here. As she said previously, we will be talking about cleaning, sanitation, and monitoring today. And specifically, we're talking about our produce packing houses and produce settings when we're talking about this cleaning, sanitation, and monitoring. So let's get started. A little bit about kind of who our main enemy is when we're trying to clean and sanitize and use those monitoring activities to make sure that we're preventing foodborne illness. And that's bacteria. And the reason why we're primarily focused on bacteria is that unlike other pathogens, if we give bacteria the right conditions, it can multiply outside the host. So if you're familiar with viruses and parasites, they need a host in order to multiply. So generally, when we're thinking about issues out in the environment, we're really referring to those bacterial pathogens. And if you know anything about the conditions for bacterial growth, we know that when we give it the right conditions, they can reproduce very quickly as every 20 minutes. And bacterial growth is exponential. So when we're thinking about these bacteria reproducing, we're thinking about them actually physically splitting in two. And so they're creating double the amount of bacteria as quickly as every 20 minutes. When we give bacteria the right conditions to grow, they grow and they grow quickly. And when we're referring to those conditions, we think about these as fat tom, or we refer to these as fat tom. And fat tom is food, acidity, time, temperature, oxygen, and moisture. And when we give them those correct conditions, which are necessary for their growth, then they're able to persist and reproduce in our environment. Another thing to note about bacteria is that when we're referring to foodborne illness, bacteria is the largest contributor in produce. So bacteria are not only responsible for the majority of outbreaks that we have, with over 85% of outbreaks related to produce, but they also contribute to the largest number of illness, hospitalizations, and death by far. So when we're thinking about our cleaning and sanitation programs, it's even more important because this is where we really have the opportunity to prevent these kinds of issues from happening. And one thing to note about bacteria is that when we allow them into the environment, they do a really great job of finding a home and reproducing. And typically what happens when we neglect our cleaning and sanitation programs, we find issues like biofilms. And what biofilms are is a collection of microorganisms that have attached to a surface. They release these polysaccharides or carbohydrates, which are really sticky. They have sugars in them, and it allows them to attach to a surface and then start multiplying. So you can see in this graphic on the right-hand side, we have this planktonic bacteria, which are these little free-floating bacterial cells. They start to adhere to a surface by releasing these polysaccharides and start to proliferate. One thing to note is that it is not only pathogens that get into these biofilms. These are very multicultural or multibacterial species, like apartments for bacteria or condos. And so not only can you have maybe something that's pretty benign that starts to form a biofilm, then it can stick to other pathogens and cause issues. So as these bacteria make these little apartments or condos, they start to mature. And then at some point, they start to actually disperse bacterial cells into the environment. And so long-term neglect of our cleaning and sanitation can result in not only these bacteria creating a home, but starting to reproduce and then proliferate in our environment. So that's why we use these effective cleaning, sanitation, and monitoring activities to prevent the establishment and persistence of biofilms. So let's talk about the importance of cleaning. To reiterate the importance of cleaning, and I think, Armando, do you have a question?
Yes, I have a question. Since you're talking about biofilm, and you only mentioned bacteria, is it possible like you have like any microorganisms other than bacteria? And secondly, like can it be like fungus or like any other microorganism? And secondly, how does that can affect the removal of a biofilm?
So I am not sure how the addition of fungus or other organisms might affect the biofilm. I know that when sugars and things like the food is released into the environment, then certainly fungus can benefit from that environment. But I'm not sure about the interaction of biofilms, bacterial biofilms with fungus. Hopefully that answers your question. Okay. So again, when we're talking about the importance of cleaning and sanitizing, it's important to note that our fresh produce receives no treatment step. So there's no kill step to remove contamination that might have occurred along the supply chain. So everything that touches produce, whether it be a food contact surface like our hands, surfaces of tables or our harvest bins, they have the potential to contaminate our produce. So when we're thinking about our food contact surfaces in our environment, we need to think about the cleaning and sanitation of our harvest containers, any of our packing equipment, hands and clothing, and post-harvest water. It's also important not to neglect those non-contact surfaces because they can also have an impact on food safety. So it's important to note in your environment how things might interact with those surfaces, like brooms leaning against walls, or your feet and how foot traffic moves throughout your packing house or your packing area. So while we focus mostly on our food contact surfaces, we certainly want to also keep in mind that our non-food contact surfaces can impact our food safety as well. Jimmy said, did you have a question?
Yes, I actually did. So when you're handling food, so I know maybe you would use gloves. Would you suggest sanitizing those gloves that you use? And also for the sake of the area you're in, such as the walls, maybe some form of heat to maybe sanitize the walls as well, because of course the environment itself would impact the produce as well.
So I'll first start with gloves. Number one, it's important to have a very rigorous hand washing policy to ensure that people are washing their hands properly before they're donning those gloves. And then a glove policy is also important because you want to make sure that your workers are using either single-use gloves, which are presumably clean, or cleaned and sanitized reusable gloves. And that they're also monitoring those gloves to make sure that they're intact, not in disrepair, not soiled in any way, and that they know to change those when they are. So that goes back to the importance of a worker training to ensure that your workers can detect when their gloves are not intact and when they need to be changed. The second question was using heat in our adjacent surfaces. So I do not know of necessarily a heat treatment that we might use in our packing houses. I know that in laboratories, we use UV light. So that could possibly be an opportunity to use UV light in some of these environments, but it's not, to my knowledge, it's not used very frequently. Generally, it's just going to be that manual cleaning and sanitation to reduce our risk of those adjacent surfaces. Okay. So let's move into the different types of cleaning. So it's important to note that when we're talking about the produce industry, we're talking about an array of produce types, whether that be something like a tropical fruit to an onion to a watermelon. And we're also talking about an array of packing house environments or packing environments. And so it's important to note that depending on our environment and our produce commodity that we're referring to, wet cleaning is not always the best approach. If it's a generally dry environment, we might not use wet cleaning in all of our packing environments. So I'm going to skip down to dry cleaning and then go back to wet cleaning. But dry cleaning might be used in packing houses that handle foods with low water activity. We see this used most frequently in places like nut packing houses or onions, something that water is not a part of the packing process. And the reason for this is because if you remember back to one of those first slides where the needs of bacteria or fat Tom, moisture was one of those needs for bacteria to reproduce. So if we can eliminate one of those factors, we're better off to not add water to that environment if it's not a necessity. We may also use dry cleaning in between our wet cleaning. So we've determined that this is something that we can effectively do through sweeping, vacuuming, different things to help remove that organic matter and that dirt from that environment. So again, some of our options are sweeping, brushing, vacuuming, blowing, and blasting dry ice, which is something that's used in more facilities than packing houses. So wet cleaning is the one that we are most familiar with. It's the one that we probably use most often in our daily lives. And this includes the addition of water in our cleaning process. And then we'll also use a detergent or surfactant that helps aid in the removal of dirt. So generally, they're going to have that foaming property that's going to help remove that dirt from that surface. The one that you might most use often in your lives are Dawn dish soap and things like that. And you can really see the lifting power that some of these surfactant type chemicals use. So we've talked about cleaning and sanitizing, but I think before we move on to this processes of cleaning and sanitizing and the actual steps in doing it, we need to recognize the differences. When we talk about cleaning and sanitizing, oftentimes people think of it as an interchangeable event, and they are not. So cleaning is the physical removal of dirt or soil from surfaces, and this includes the use of clean water and detergent. Sanitizing is the second step in the process. So sanitizing is the treatment of a clean surface to reduce or eliminate microorganisms. It's important to note that you cannot sanitize a dirty surface. Cleaning always comes first. And the reason for this is that many of our sanitizers are sensitive to organic matter that might be present on our tools and equipment or packing lines or whatever surfaces that we're trying to clean. And so by applying that sanitizer before you clean that dirty surface, you're inactivating your sanitizer and essentially wasting money and not performing the job properly. So we always want to make sure we're removing that dirt, debris, any kind of organic matter from that surface before we try to sanitize. And we'll talk about next, what are the 4 steps in order to do this effectively? Bethany, did you have a question before we move on? Okay, I don't see her coming off mute, so maybe I missed her.
Oh, no, I just did it. I'm sorry. I had a mishap with my internet. But in terms of
problem.
like the cleaning and sanitizing, I know a lot of people tend to use bleach as both a cleaning and a sanitizing in this type of situation. So how necessarily does it work? Is the bleach supposed to be used mainly for cleaning, or is it mainly for sanitizing?
So that's
In
a
terms of-
fantastic question. And you're probably relating it to like a Clorox cleanup or something that we use in our households. And you'll see in our commercials that they're spraying it right on food debris and dirt on their countertops or whatever surface that they're trying to clean. And essentially, they're doing it wrong. So you want to remove that food debris and make sure that you have that organic matter off of that surface before you apply that bleach, because again, it's just going to eat up your effectiveness. So that's a fantastic question. We want to first clean the surface, remove that debris, and then sanitize with that bleach product. Okay, so let's jump into the steps of a cleaning and sanitizing process. So the first step is the pre-rinse. So we're applying that water to remove any kind of soils and the bulk of the organic matter. It is important to note that sometimes people elect to sweep their surfaces or manually remove the organic matter, depending on what the surface is and the area that they are trying to clean. But by removing that initial soil and bulk of the organic matter, it allows us to better penetrate, have better penetration of our detergents and cleaners, and that water also aids in the transfer of that as well. So you can see, again, we're using that water to push that debris off of that food contact surface. We might also use a brush to sweep it off, whatever, to remove that initial load. The second step is the cleaning step. So we're going to add that detergent that's going to help us aid in the removal of that soil and organic matter that's left behind after our initial removal. And then add some scrubbing, right? Some elbow grease. So we're going to physically remove that dirt and debris from that surface with a brush or different tools, whatever is appropriate for its use. And again, the purpose of this is to remove that food for bacteria and other pests that need to survive. So if you think back again, that food was the first part of Fat Tom. And so food is important here. We're going to remove that food that's necessary for that bacterial growth. And then we're also going to eliminate residual soil. So again, removing that organic matter that's going to physically block our sanitizer from reaching those microorganisms. So the third step is to rinse it away. And we're going to be using water that meets the post-harvest standard of no detectable E. coli per 100 mils to physically rinse that any soil or detergent that's been loosened and maybe remaining away. And it's important that improperly rinsing surfaces may neutralize your sanitizer because you may still have that residual organic matter. So while it may seem like an easy step, it's important to make sure that it's done properly. And then finally, the fourth step in our cleaning and sanitizing process is to sanitize. So we're going to apply an EPA labeled sanitizer that's approved for use on food contact surfaces. And we'll talk about what EPA labeled means here in a second. And again, the purpose is to remove those remaining microorganisms. So to relate this back to our daily lives, it is like going and washing our hands properly and then applying a hand sanitizer to reduce the remaining microbial loads. So when you are applying that sanitizer or mixing that sanitizer, you want to make sure that you're following the label. these labels and the companies have formulated these sanitizers in a way that is appropriate for whatever is on the label. So it's important that you follow that, whether it be the prescribed mixing instructions and contact time, or whether it needs rinsing.
Looks like we
So I
have,
see a couple hands raised. Did I miss some questions? And I'll start with Maxo.
Yes. Is there a water quality standard for the water used for cleaning and sanitation?
Can you repeat your question? I think your voice might have lagged a little bit with the internet.
Is there a water quality standard for the water used for cleaning and sanitation?
Yes. So fantastic question. The water that we use in our cleaning and sanitation must meet the post-harvest standard, which is no detectable E. coli per 100 mils of water that's tested. So that's a fantastic question. Joy, did you also have a question?
Yes. So, based on the 4-step cleaning and sanitizing process that you just talked about, it was all for wet cleaning. How would this differ if we were doing dry cleaning? Do they have detergents and things like that for dry surfaces and like dry sanitation?
Yes, so that's an awesome question. So for today, I focus mostly on wet cleaning. When we are dry cleaning, the major focus of our dry cleaning steps is going to be the removal of that organic matter. So there's going to be even more emphasis on step 1 to remove that organic matter physically, either through brushing, vacuuming, sweeping, something like that. There is a little bit of a difference in dry cleaning because sometimes when you apply a sanitizer, which are often water-based in these environments, it's not always best practice. So it's really situational. Oftentimes when we think about dry cleaning, we're not actually doing our sanitation process at the end. And so in our dry clean environments, we might dry clean in between an actual large breakdown and wet clean, if that makes sense. So because we're adding water to that environment, we may actually be adding that moisture, which is necessary for bacterial growth, and it might not be as effective in the big scheme of things. Okay. Ashley, I see your hand raised. I'm not sure if you have a question.
I do have a question. So we actually have a farmer who is with us today, and they had a question regarding the use of rags, like when you're cleaning. The question was, are you suggesting that we use 2 separate rags, one for wiping and then one for actually cleaning the surface?
So that's a fantastic question. When you're using rags, it's important to note the role that they might play in cross-contamination. So the suggestion to use 2 different rags to remove that original organic matter before you actually use for cleaning and sanitation is actually a really fantastic idea, because if you have a soiled rag from our initial removal of that organic matter, there's a high possibility that you're also spreading that organic matter throughout your activities down the line. So yeah, that's a fantastic suggestion and great risk assessment there. Okay. Any other questions that I might have missed?
Yes, I had a question.
Okay.
Would you suggest air drying or using a paper towel maybe to prevent, the other bacteria in the air to contaminate?
So air drying is always a really good idea. Generally, when we have surfaces that are wet for long periods of time, we want to try, the goal is to get them dry. So depending on the material, a paper towel or some kind of single-use towel or clean towel may be appropriate to aid in that drying process, and then maybe we'll follow up with an air dry. If you're referring to sanitizers, a lot of times the label will say to actually let them air dry and leave them there. So we wouldn't want to wipe that sanitizer off. We want to leave that there to allow that contact time. And generally our sanitizers are going to dry pretty fast depending on our environment. In terms of bacteria in the air, that's certainly something, depending on our packing house setting, that may be a little bit hard to control. So we want to try to have some kind of dust mitigation or think about our airflow to help mitigate some of those issues. Okay, any other questions?
Oh, I had another one as well. So I know that certain like places actually have like different surfaces, and not all sanitizers and cleaning products tend to work on it. It more or less just deteriorates the actual surface itself, which causes like more complications. So like even though we're properly cleaning it, like there's still an issue of the actual surface itself still showing like a sticky residue because of the deterioration. So is there like a certain, not necessarily, well, you could say a certain process that, even though I'm not sure if you actually mentioned it here in terms of the 4-step cleaning process, like, is there a certain way to where we like have to do, I'm not sure how to word this, but basically like try to figure out like the best way to still clean it without deteriorating the actual surface itself?
Yeah. So we're jumping ahead there. I'm going to park and lot your question because I'll bring it back up here in a bit. But we will talk about how it's important to select a cleaner and sanitizer that's complementary of your packing house or packing surfaces. So let's come back to that, okay? Yeah, sure, Ashley.
So a farmer also wants to know, how long should we use sponges if we're using a sponge for our cleaning process? Like how long should we use that sponge until we need to replace and get a new one?
So sponges are a tricky material, right? They have a ton of surface area, which is can be an issue when it comes to cleaning and sanitizing. They're very, very hard to clean. So we want to make sure first that if we're using something like a sponge, that we're not using it improperly where it could possibly contaminate as you were trying to clean and sanitize. So sponges, I would recommend against sponges because they are hard to clean and sanitize. It is something that you have to determine what's best for your environment, but you should know the risk that comes with sponges. I would prefer that you would use something that could either be laundered or could be single use, as sponges are very, very difficult to clean. And it's hard to change our thinking around that because it is something that we use probably within our own households. It's something that we associate with cleaning and sanitation. But again, sponges are made of that really nice porous material, which are very difficult to clean. And maybe not be the best suited for our packing environments.
Thank you, Taylor. I also had one more question from a grower. They wanted to know, like, when it comes to sanitizing a surface, if you're using like a sanitizing wipe, do you just use it for that one? You can only use it for one item and then you need to get another sanitizing wipe? What would you recommend for that?
So the first thing, and we'll talk about this here in a bit, is to make sure that our sanitizing wipe is labeled for food contact surfaces. It has that EPA label or registration on it. So that's the first thing to think about. The second thing is to determine if there's still sanitizer there, if you think it's still acting effectively. The difficult thing about wipes is that there's probably no strict standards to say whether it's effective or not. So it would really have to be up to the person who's using it to prescribe what they think is the best use and that it's still being effective. So
Thank you.
the quick answer is that it depends, right? Which is the answer to a lot of questions, unfortunately. But yes. Any other questions? Okay, let's move on. So kind of similar to what we were being asked about earlier, when we're selecting our sanitizers to make sure they're complementary of not only our environment, but the organic matter that we might have, or our fruit or vegetable residues that might be left over on those tools or those packing lines. We need to make sure that we're selecting the correct chemical cleaner. And so we're talking about detergents here. Again, selection is going to be based on the type of soil that we have in our environment, what kind of equipment that we have. Are we using a soft metal equipment or something that maybe is less sensitive? So it depends again on your environment and the tools and equipment that you have in your own packing house. What kind of cleaning methods? Some of them have foaming properties, some of them do not. It's really dependent on your environment, again, in your farm. One thing that we do recommend is work with a chemical supplier who can help you identify a chemical that's most suitable for your operation. And so these people are the most knowledgeable about all of their products, and they can make the best recommendations. But when we're thinking about a produce environment, we're really concerned about these three different classes, I guess, or characteristics of food, of residues that'll be left over. So a lot of times with our fruits, they have a lot of carbohydrates. They're going to be leaving a sugary type residue. And so we'll probably use water, because carbohydrates are water soluble, and some kind of mild alkaline detergent to help us remove that organic matter and that sugary residue that's left over. If we're packing something like nuts or avocados, which are generally more fatty and have more oils, again, we're going to be using something that's water soluble. We might take advantage of a little bit of heat if that's an option, to help us actually remove those fats that are left over. So again, an alkaline detergent, we may have to use something that's stronger in alkaline if necessary. And then for starchy foods, fruits and vegetables, again, that alkaline detergent is going to be probably what we would select, depending on our environment. So now we're switching gears. We were talking about detergents. Now we're going to talk about sanitizers. So we're moving on to talk about sanitizers. Sanitizers are where the complexity comes in, right? So a lot of times we have a lot of options available to us. We have chlorine, peroxyacetic acid or paracetic acid, hydrogen peroxide, quaternary ammonia, and ozone. And there's also more. But these are the most common. So when we're selecting our sanitizer, we need to make sure that we are selecting one that best fits our operation and best fits our ability to manage that sanitizer. Chlorine, or we've already talked about bleach, is something that is readily available. It's generally very affordable. But it does require more management. So when you are thinking about applying a chlorine sanitizer, you need to take into account different things like pH. What is the pH of the water that you're mixing that sanitizer with? Does it need to be buffered? And then what is my free chlorine that is available to sanitize within that water? And so sometimes we think of chlorine as something that's widely available. It's something that's inexpensive, but it is a little bit harder to manage. Another common sanitizer that you'll find in produce packing houses is peroxyacetic acid or paracetic acid. One thing to note about this product is that, again, it's readily available. It's generally user-friendly. It's something that you can follow the instructions, mix up, and then just test the concentration, and it's generally ready to go. And it is less sensitive to organic matter. So when we're thinking about adding that sanitizer to water and using it on surfaces, it's less sensitive to our organic matter than chlorine. Hydrogen peroxide is one that, again, is also readily available, but it's a little different because it is sensitive to organic matter and might be used in combination with PAA or peroxyacetic acid. One thing to note about peracetic acid or peroxyacetic acid is that it is a little bit corrosive and it is a little more expensive. So it really, you kind of have to weigh your options. Do we have the time and the know-how to manage chlorine properly? Or is it easier to spend a little more money on peracetic acid or PAA and it's more user-friendly? Some lesser used, but still very effective sanitizers are quaternary ammonia. Excuse me, my mouse is jumping me back. Quaternary ammonia and ozone. Quaternary ammonia is something that's used a lot in the restaurant industry or food service industry. It's very readily available and generally non-corrosive to surfaces. But it does cost a little more and it may require rinsing after using. So it does require a little bit more labor depending on the product. And then ozone is also a very effective sanitizer in large facilities and operations where they are sanitizing large volumes of water or different areas. You might see ozone used. One thing to note is that it requires a lot of expensive equipment. It is very expensive to maintain, and you might have some worker health concerns if it's not working appropriately. So it's really important if you're in an ozone environment to make sure that that machine and equipment is working properly. So let's talk about our considerations when we're selecting a sanitizer. Again, we want that surface that's being sanitized to be hard and non-porous. You might have thought of wood, and we can chat more about wood here in a bit. Wood is generally something that is a little bit harder to sanitize, right? So we really have to make sure that we're getting it clean, we're applying that sanitizer, and we're allowing it to air dry appropriately. You might see in this picture, there's some other surfaces that are not hard or non-porous. And so we want to, in our packing areas, eliminate these surfaces as best we can. You can see that they're used to help prevent this fruit from bruising or being damaged by the packing equipment. But we want to try to eliminate these surfaces again and use something that's easily cleaned and sanitized. The next thing after we consider our surface is to consider that chemistry that meets your needs. There are chemistries or sanitizers available that are certified organic. So if you are, an organic producer, you need to make sure that you're using something that is approved by either NOP or OMRI, which are certification bodies for the organic certification. Understand that depending on the chemistry, you might have worker safety issues. So if our chlorine becomes too hot, it might off gas and have worker safety issues, or maybe we're using an ozone machine and it's not working properly. So note that that is also a concern and a consideration that you need to make. And then the ability to monitor the effectiveness. So again, we talked about chlorine and the importance of pH and how that really can have an impact on its effectiveness. So you need to make sure that it's something that you have the time to do and the capability. And then lastly, it must be EPA registered. And so this is a requirement by law. So when we think about that EPA registration number that we're looking for on our sanitizer, Sanidate 5.0 is a PAA or peroxyacetic acid sanitizer that we use a lot. This is just a sample label to show where you might find an EPA registration number. So you can see the EPA registration number is 70299-19. And what this indicates, the first part of that is the manufacturer. So it's been manufactured by BioSafe Systems. And then the second part of it is the product number. So it's product number 19, which indicates Sanidate 5.0. So you'll find that EPA registration number on a lot of sanitizers, but you need to make sure that it is there and that your sanitizer is labeled for its intended use. Okay, so after we've determined that we can clean appropriately, we know what steps are used in our cleaning and sanitizing process. We've selected a sanitizer. We've put it to use on our operation. The third thing to do is to monitor. And we use monitoring activities to ensure that the job is being done appropriately and effectively. So this is someone physically going back and observing that these things are being done properly. So for our monitoring activities for cleaning, we're going to use visual assessment. This is just, again, looking to make sure that we have removed that organic matter, that fruit residue, any dirt and debris. And then for sanitation, we're going to use some tools and equipment and instruments to ensure that we're sanitizing things properly. And it's important to note that in our monitoring activities, we might use record keeping to write down these actual activities that we are observing. So for monitoring activities for cleaning, again, we're going to really focus on that visual inspection. Our goal for cleaning is that it's going to be visibly clean. And I cannot stress this enough because we'll talk about why this can be a little bit hard to achieve here in the next couple of slides. So again, we're using our eyes, maybe a flashlight, magnifying glass, whatever we need to observe our area properly. And we're going to be looking at our tools and equipment, our packing line, packing area, and any adjacent areas after we do those cleaning activities. So I first want to talk about, before we talk about monitoring of our sanitation activities, I want to talk about what does visibly clean look like? Because we ask our growers and our producers to do this on their operations. And I think we gloss over it and we don't really talk about how difficult some of these surfaces and areas can be to achieve visibly clean, which again is our goal. So I want you all to look at the picture that's on the slide and tell me if you think that this is visibly clean. Feel free to come off mute, make any comments. Tell me what you see.
I would say no.
No? Okay.
It looks like there's some specks
Denisha.
on there.
Okay.
White specks on there.
So it might be hard to see on the slide, but these are actually spider webs. So either this packing equipment or these brush rollers, which is what these are here, has not been used in a while, or we have not cleaned them to the point where they look visibly clean, right? Most of our other surfaces look pretty good when we're looking at these PVC rollers. Some of our sides here, everything looks pretty good. I will say that when you're actually physically trying to clean these brush rollers, it is very, very difficult. So sometimes our settings are not always easily cleaned. And so while our goal is visibly clean, it's very hard to achieve that. So let's look at the next one. What do you see here?
Still those, well, whites kind of looks like splatters from what I'm looking at.
What do you think that looks like? You
Maybe
might see
paint?
this on your car. If you park under a
Bird
tree.
I was
feces?
thinking milk.
Yeah.
What?
Yep. So that's bird poop that's splattered on that packing line. So likely in our monitoring activities, we've detected a pest control issue, right? We've have some birds that have made a habitat of our packing area. So that's something to report back and make sure that we are identifying the issue and making sure we're fixing that issue. But it's not visibly clean, and there's definitely a risk of contamination here. So we need to have this re-cleaned and sanitized before we put it back into use. Okay, so this one might be my favorite one. What do we think about this one? How clean do we think this is?
No, that looks like mold along the rollers. Personally, yeah, I don't feel comfortable
Okay.
with that.
Any
Are
other
these-
comments from anybody?
I'm not sure if we're supposed to be commenting on the fact that none of them have gloves on.
Okay, so that's a good comment. So gloves are not a requirement of the produce safety rule. The requirement is that we wash our hands appropriately and effectively. So they're not required to have gloves in this environment, and sometimes gloves may not be the best approach, actually. So we'll first start there. Let's come back to what we're seeing here. Does anybody else have any comments? So it's really hard to tell, right? Whether it's clean or it's just stained. A lot of times in our packing areas, we use our equipment for long periods of time and they show wear and tear. So in this picture, for me, it's really hard to tell whether it's clean or not. It's something that has to be looked at, maybe felt while you're in that environment. Likely this is a residue that comes from waxing when we're waxing fresh citrus to go into the fresh market. So whether that's clean or not is really, really hard to tell. It may very well be clean. So again, you kind of have to be there to use your organoleptic senses to make sure that things are clean. What about this one? What do we see here? Any comments? It's not a trick.
There may be, I think I see black, like some black specks on the green portion. Maybe some mold
Yeah,
there.
so it's used. It's not mold. Mostly this is just painted metal that has been used. Paint removes over time, so it's just worn. To me, nothing indicates that this is not visibly clean. Okay, so it's something we see all the time is that our packing equipment is used. But I don't see any organic matter. I don't see any residues that would indicate to me that it's not visibly clean. What about this one? Any comments here?
I do see, like, is that like a leaf, like right next to the finger? I don't know. Is that a leaf?
Mm-hmm. Yep.
Yeah.
Okay, so we've got a spider web here that is holding some kind of leaf debris. We've got a leaf here in this crevice, and then you can see there's quite a bit of organic matter built up along this top area up here, right? So to me, that's not visibly clean. One thing to note is that these areas are very difficult to clean. So what we're asking our growers to achieve can possibly take a lot of time and effort and might not always be feasible for what they have going on. So this is where it's important to use the correct materials as you change out equipment, that you design things or purchase things that are designed to be easily cleaned. And that's something that's not always been taken into account by engineers who are designing packing house equipment. So it's really important to do these kinds of inspections, determine if it's visibly clean before we do our sanitation, because likely our sanitizer is not going to be effective along these areas. Okay, so moving on. Thank you all for helping me with that exercise. Let's talk about the monitoring activities. So we've cleaned things, we have monitored to make sure that they are visibly clean. before we move on to our sanitation activity. So after or during our sanitation activity, we're going to use, if we're using a chlorine sanitizer or something that is pH sensitive, we might use test strips or pH meters to make sure that our pH is within the appropriate range. So for chlorine, we want to be in that 6.5 to 7.5 pH range. A lot of times in Florida, we have very alkaline water. So it might have to be buffered with an acid to let us achieve that 6.5 to 7.5 range where our sanitizer is most effective. For our concentration, and this goes for all of our sanitizers, we might use test strips or titration kits to make sure that we're achieving that correct concentration. And then if we're using chlorine or something and we're heating our water, we might also monitor our temperature to make sure that we're not dropping or raising our temperature too high and have some chlorine off-gassing. Okay, so we've talked about monitoring activities. The next thing is, what happens if our monitoring activities indicate that we have an issue? We've identified a problem. So what do we do next? So our first step is to assess the situation, right? We just need to figure out what's going on. Determine if there's been any product that's been affected. So do we have dirty packing equipment? Have our harvest bins not been cleaned by the crew before them? So we got to figure out if they've been used, if any product could possibly be contaminated, and how much, and identify that, and then decide what you need to do with that product. Determine the cause of the problem and what needs to be done to correct it. Is it a worker training issue? Do we need to retrain our workers or reprimand our workers because they did not follow policy? Do we need to contact our supplier, our sanitizer supplier? We've determined that we can't get it to mix properly. We're out of sanitizer. Whatever might happen, we've got to determine, again, the cause of the problem and what needs to be done to correct it. And then in the future, we're going to adjust our practices to help us address the risk and monitor to make sure that those corrective actions has fixed the problem. So again, some examples. Our previous worker mixed our sanitizer improperly. We might have leaf or fruit debris or residue on the packing line after cleaning, or we might have some dirty harvest equipment or containers that might need to be rewashed and sanitized. Okay, so after our corrective actions, the produce safety rule, if we have growers who are complying with it, requires records around cleaning and sanitation for our equipment, tools, and surfaces. So for the produce safety rule, they require that you include the date and time, the name or initial of recorder, and what activities were performed. Even if growers are not covered by the rule, it's a really great way to make sure that you are conducting your practices at the scheduled time to ensure that your workers are completing practices properly, and to just make sure that you're implementing your food safety program effectively. So some other worker training records around cleaning and sanitizing that you might also need to include would be workers' names and signatures, training topics covered, the date and time, and the name of the trainer. So you want to include any records around training, if they were trained on cleaning and sanitation activities. And then for the produce safety rule, records should be kept at least 2 years. So if you're covered, you need to keep those records at least 2 years. If you're not covered, it's still best practice. All right, so these are my resources. I use the National Good Agricultural Practices Program, the Produce Safety Alliance, Cornell GAPS, and again, this project is funded by USDA and NEFA. So with that, I will end my presentation and entertain any questions that you might have. All right, did we answer them all along the way? Feel pretty good about cleaning and sanitizing now? Awesome.
Yes, definitely.
Awesome. Glad to hear that.
Well, thank you, Taylor, for this great presentation. We learned a lot about cleaning, sanitizing and monitoring. If you guys have any other questions, please feel free to email me, email Harriet and the team at FAMU, and they'll be able to get those questions directed to Taylor. But thank you all for your participation, and thank you again, Taylor, for the great presentation.
Absolutely. Thank you all for having me.